Hello, everybody. Glad to be with you again with a huge assistance of this webinar about tunnel solutions. With me, we have David Vargas, engineer developers of tunnel solution for Total Station, and Francisco Navarrete, who will make a demonstration of TCP Scansir, our general manager, with me. Let me introduce myself. I'm David Vincent, in charge of the international sales, and I will introduce quickly ApplyTop for those who don't know us. Please note that you can proceed to all your questions. You have a small part to put all your questions inside, and we will try to reply all of them during the webinar, or if not, we will send you the reply later on by email. Please note this webinar is recorded and you will find it into our webpage, and YouTube. Okay, so ApplyTop is a Spanish company based in Malaga, in the south of Spain, and we are software developers for surveying and civil engineering. We have a huge success with much more than 15,000 users licensed worldwide, and we work through distributor previously selected in order to be able to give a first local support. Our success is mainly because we offer licenses, permanent licenses, and as you will see, very easy to use, really pragmatic on their use to give a perfect reply in your daily work. One pillar, or one of the most important things about ApplyTop, it's our department, our after-sales service department, which gives support to final clients with maintenance and to our distributor for the local support. We offer, of course, different kind of training from basic to advanced, on presential or online. And we have created a new channel, YouTube channel, where you can find a lot of information about our solution with different subtitles in different language. So don't hesitate to consult them because there is a lot of language available. Different agreement about our quality, like ISO 9001, and also we give to our clients, we proceed to survey in order to detect the specific needs to each market in order to develop our software and having always a very concrete solution for you. Some innovative project we develop so much for private entities as well as public project like Roadbeam, AutoBeam, Pandora, that I invite you to discover into our webpage. Some universities and associations we work with, like for example, Land XML for the generic format to exchange data, or now to BIM. We are involved and pioneer in the development of BIM format, IFC format, and exchange solution on this way. What about our software? What they are able to do? How our applications are able to do a lot of kind of project. Today we will see about how to manage with Total Station or with laser scanner, tunnel or mine projects. One thing that it is really important is our development partners are so much on Android, Apple, S3, Intel, and Microsoft, which allow us to be CAD cross-platform, Autodesk, Brixis, and ZVSoft with their respective solution as AutoCAD 21, BricsCAD 20, and ZVCAD 20. This is some agreements we have with several companies about they let us their last instrument in order we connect our software with them, or able to import export our with our software with all these brands. It's not an exhaustive, but this is more or less the most updated. Full range of family software in Applitop is not only about tunnel solution. We have software for surveying projects, for field work, so much on Android and Windows, so much for photogrammetry. About our current research area actually are to work with in point clouds, in augmented reality, drone for drone, and BIM for infrastructure, as I told you before. Some national reference, we work with the most known contractor in the Spanish market, like SACIR or Acciona, or we have also a great relation with universities in Madrid. And about tunnel project, we have relevant projects like underground of Mumbai in India, underground of New York, underground of Riyadh, which is 12 line down in the main time, the highway of the UK where you have parts of tunnels or Panavial or underground extension of the underground of Ottawa. Also, it is proceeded by our software. So this is a relevant project all around the world, giving the guarantees that our solution for tunnel are really pragmatic and very good solution for your job. And thank you and for your attention. And now I will follow up with my colleague, David Vargas. David, are you with me?
Hello. Yes, David.
Okay, please share.
Can you see the screen?
Yes, please go ahead.
Okay. Hello, everybody. My name is David Vargas. I'm going to talk about the tunnel solution we have in Applitop. First, I'm going to do a short introduction, and then after this, we are going to do a demonstration of the program. In Applitop, we have three applications. TCB Tunnel for Total Station, TCB Tunnel CAD for CAD, and TCB Scanser. TCB Tunnel for Total Station allows you to stake out, check, and survey cross-sections with Total Station. With TCB Tunnel CAD, you can process the data surveyed with Total Station, and it runs on CAD programs. And TCB Scanser is a desktop application with integrated CAD for processing point clouds measured with a laser scanner. TCB Tunnel for Total Station is compatible with Windows CE devices, and now we are working on a new version for Windows 10. It can be installed on data collector and on board in Total Station. Is compatible with many Total Station brand and models, which can be robotic and mechanic. The main functions of TCB Tunnel for Total Station are project management, including point files, horizontal and vertical alignments, tunnel templates, etc. Surveying cross sections and grid. Also, it's possible to do a survey of single points, checking cross sections and control points, and also cross-section drawings. Stake out functions such as face, rock bolts, and cross sections, and also some tools and configuration functions. TCB Tunnel CAD is compatible with Windows from 7 to 10 and different CAD programs such as AutoCAD, BricsCAD, and ZWCAD. The main functions of TCB Tunnel CAD are project management with powerful alignment editors, horizontal and vertical alignment definition and tunnel templates, cross-section calculation and drawing, area, volume, and point reports, and also 3D model and virtual tunnel route. TCP Scansir is compatible from Windows 7 version. It doesn't depend on an external CAD and allows you to import in a wide range of file formats. And his main functions are project management, like the other programs, tunnel template and alignment definitions, cross-section calculation and drawing, report management, 3D model and virtual route, and also impedance map. And now, before doing the demonstration, I'm going to talk about the workflow of TCB Tunnel. As you can see on the slide, the first thing we have to do is create a project in TCB Tunnel CAD. After doing this, we import this project to TCB Tunnel for total station, and then we can do the survey in the field. After doing this, we import the surveyed data in TCB Tunnel CAD and do the cross-section calculation, drawing, report, etc. And now we are going to do a demonstration of TCB Tunnel and Tunnel CAD and also TCP Scansir. Then the first thing we have to do is to create a project folder with the file of the project. In this case, we have a LAMP.XL file with the horizontal and vertical alignment, a control point for the total station to do the positioning, a drawing with the tunnel template, and these are the three files we have to create the project. Then we run AutoCAD. In AutoCAD, we have the TCB Tunnel menu. We have options for creating the project, to edit the tunnel templates, the calculate cross sections and reports. And then the first thing we have to do is to create the project. We go to the project folder, enter the name of the project, and then we have the project property page. We enter the name, the author, and then we have to select the horizontal and vertical alignment of the project. In this case, we can select directly a horizontal and vertical alignment from TCP entity, or we can import from LAN SML. In this case, we are going to import from LAN. We go to horizontal alignment editor. Then we open the LAN file. We enter the name of the horizontal alignment file, and then this is the horizontal alignment of the project. After this, we do the same for the vertical alignment. We go to the vertical alignment editor. We import from the LAN for the same file. We set the name of the file, and this is our vertical alignment file. Then after this, we select the control point we are going to use in total station. And then we select empty tunnel template file. The project is created, and then we can add the tunnel template of the project. We open the tunnel template drawing, and then we go to edit tunnel templates. In this case, we have only one tunnel template. We click on new, select the polyline of the tunnel template, enter a name for the tunnel template, and then we have to set the horizontal and vertical application points. Then we press OK, and we have our tunnel template in the project. After this, we have to go to tunnel template assignment. In this case, we have only one tunnel template, but in case we have more than one, we have the list of the tunnel template, and here we enter the final station to apply the tunnel template. The tunnel template will be interpolated automatically. Then in this case, we have only one tunnel template for all the horizontal alignment. And then after this, we can draw the theoretical tunnel. We go to TCB tunnel, draw tunnel. And now we can see the tunnel in 3D. This is our theoretical tunnel. And then after this, we can export the project to Total Station to do the survey in the field. Then I'm going to run TCB tunnel. This is the new version for Windows 10. We select the project. We go to the project folder. This is the main menu. Here we have the components of the project. And the first thing we have to do is to create a point file to store the points. New file, Crosssections. And then after this, we have to go to position option. In this case, there are several options to the positioning of the total station, but in this case, we are going to use the resection. We select the standing station, and then we are going to measure the different control points. Select the control point 1 and measure. Select the next control point, measure. Now we have coordinate, but we are going to measure a new control point. A third control point, measure. And now we have the result of the calculation. We press OK. And now we can go to the different options of surveying and staking out. Then we go to survey, cross-sections, and now we are going to enter the theoretical points we want to measure. We have different criteria to create the theoretical points. In this case, we are going to select the length and 1 meter, and this is the theoretical point that will be measured in the field. After doing this, we can enter the initial and final station and the station interval, in this case from 100 to 104 and 2 meters of interval. And then here we can start the cross-section measure. Below you can see the theoretical station, the measure station, and the difference between the measure point and the tunnel template. For each point, the program tries to find the theoretical station, and we can change this number of iterations. After finishing the cross-section surveying, we can go to checking options, for example, to cross-section drawings, to draw the cross-section we have measured. We analyze the points, enter the station interval to meter the tolerance, the initial and final station, and then here we have the cross-section we have measured before. In this option, you can click here on info button, and then after doing this, if you press on a point, the total station will move to this point at the measure station. Also, we can calculate areas with TCB Tunnel total station. In this case, we can see the under and over excavation areas in different colors. And after doing the survey in the field, we can import in AutoCAD the points and do the cross-section drawings in AutoCAD, and we can create the reports. So we finish with TCB Tunnel total station, and then go back to TCB Tunnel CAD. We close this drawing, and then edit project, and then we select the point file we have created in the field, and we go to calculate cross-section option. We enter the initial and final station and station interval, and we select a cross-section file. Now we can see we have created 3 cross-sections, and we can draw the cross-sections. In this case, we are going to draw the cross-section in a space paper. We select the scale, paper, and individual format. And here we can select the elements we want to draw. After doing this, we can print in PDF format using publish function of AutoCAD. We are going to print only 2 pages. We select the folder. Sections. And now the program is creating the PDF. Here you can see for each point, the number of the points, the difference between the point and the tunnel template, and the point height. And on the left, you can see the project name, the author, the station, the alignment coordinates, the height of the vertical alignment, and overbreak and underbreak areas, and also the cross-section area and theoretical area. Now we have finished here, and we can see in the project folder the PDF file with the 2 cross-sections. And then after doing this in AutoCAD, we are going to select a different cross-section file. We are going to edit the project. We are going to select an excavation file with more points. And with this file, we can do, for example, a volume report. We enter the initial and final station. And here you can see the volume report with the station, the length, the overbreak and underbreak areas, and overbreak and underbreak volumes. The reports you can print in different formats, like or printed on paper, on ASCII file, HTML, and Microsoft Word and Excel. After doing this, we can use, for example, to compare different cross-section files. For example, excavation and concrete files. We enter the initial and final station. And here you can see the volume report, and also you can draw this information. Model. After creating the drawing, for each cross-section, you can see the excavation cross-sections, the concrete cross-section, and the tunnel template. And below, you can see the station, overbreak and underbreak areas, the project area, and excavation areas. And in this way, you can compare different cross-section files. And also, another important option in TCB Tunnel CAD is create a 3D model of the tunnel. We select 3D model draw, enter the initial and final station and the number of the points. And here you can see the 3D model of the tunnel. We are going to use the orbit. After doing this, you can export this model to OBJ format. And then you can open this file with a third-party program like Cloud Compare, for example. This is the model here. And this is the result of the point measured in the field. And that's all. Thank you for your attention.
Thank you, David. I'm gonna now give you hands to my colleague, Francisco Navarrete. Francisco, are you with us?
Thank you, David. Hi there.
Yeah, we see you and we are with you and we see your screen. Please go ahead. See you.
Okay, thank you. Well, I'm going to show you our application TCP Scansir. The main difference between TCP Tunnel and TCP Scansir is that in TCP Tunnel, tunnel data are measured by a total station. And in TCP Scansir, we are using laser scanner to measure the as-built data of a tunnel. We are going to create a project from scratch. We create an empty project. And the first thing we have to do is to import an alignment. In this case, we are going to select an XML file, and we select the file. You know that it can contain several alignments. We select the horizontal, which horizontal and vertical alignment we want to use, and that's all. We have here, we can see the horizontal alignment with lines, circular arcs, and spirals. And here we have the vertical alignment, in this case with parabolic vertical curves. Next thing we have to do is to import the point cloud. In this case, I'm going to select the file, and while it's importing, I'm going to show you. In this case, it's a project in the north of Spain, the city of San Sebastian. It's a tunnel of about 400 meters and was measured by a Leica C10 scanner, giving a point cloud of about 12 million points. We can measure several point cloud formats. In this case, we can import files in generic formats like ASCII text files or XYZ, E57, LiDAR, LAS, and LATH, and also proprietary formats depending on the scanner laser manufacturer like Faro, FLS, Leica, several formats, Rigel, and Topcom. The importation process in this case takes about 2 minutes. It consists on two stages. First one is to read the point file and extract point attributes, because you can process a point cloud having not only coordinate but also colors, red, blue, and green colors, and intensity. And a second step is for analyzing all points regarding the alignment. In this case, is finishing the first step, and the second one is very quick. So you will see then the result. It's finishing, and now I'm going again to this screen. You can see that it has imported 12 million points in 8 sessions. For each session, we can see the length of the tunnel and the number of points, and even the percentage, because we can import a whole file or a percentage of files. This is the representation of the point cloud, and we are going to assign a symbology. In this case, this point cloud has a color, but we are going to apply a symbology by intensity. The software has different options for controlling the view. We have typical controls like zoom, front view, right view, top view, and also we can switch between orthogonal and perspective mode. In this case, we can travel along the tunnel, and even we can change the size of the points to in case of we need this to do this. Next step usually is to filter the point cloud, and the software has different options. In this case, we are going to start by the manual option, in which we can graphically see the points to be filtered. For instance, let's suppose that we want to remove some points in the first station of the alignment. We can control how which is the interval, the station interval that we want to remove, and also we can select the radius. We can switch and see this in 3D, and even controlling the angle, we could adjust these controls to remove points belonging to the ventilation pipe, for instance. And we'll see later more cleaning options. Most important feature of the software is to calculate the calculation of cross sections. Now we are going to create a new cross section file, and then we'll input the parameters. For instance, this is the initial station, final station. We'll have we want to get one cross section every meter, and with a bandwidth of half meter, and that's all. In this case, let me show you this image for showing the calculation method. We have the standard method and regression method for calculating the cross section. Please note that we haven't still defined the tunnel template, but it's not necessary. We can compute the cross sections even without having the template. Here we can see in 3D the result, and in this area, in the connection with the gallery, we want to add more detail, and let's hide the points, and we are going to add new cross sections in this interval. That is approximately initial station, final station. We want to get in this interval, we want to get every 10 centimeters a cross section. You can see the result, and now we can see, of course, we can see cross sections in this way. It's more convenient, and we can edit the points and recalculate cross sections automatically. For instance, we want to remove these points that are not real points in the tunnel, so we can select these points and delete. You note that the cross section has been recalculated automatically, and this point has changed the color. In fact, they are moved to a different layers is for filtered points. We can continue in this way for cleaning the point cloud, and even we don't need to do this cross section by cross section, but we can apply this method for a group of cross sections. We have assigned a bandwidth of 5 meters for seeing the point cloud in front view, and we can repeat this procedure so that we can easily clean the point cloud. For instance, we can remove also the scanner, and that's all. We can repeat this procedure and clean our cross sections in minutes. Usually it takes minutes. Now I'm going to open a different project in which the tunnel, the point cloud has been cleaned, and now you will continue the presentation. Let's hide some layers, and you can see here that the point cloud has been filtered. In fact, we can hide this layer, and now we are going to define the template. In this case, sorry, I'm going to delete was previously defined, but I'm going to show you how to define the template of tunnel. It's very simple process. It's only required to import a DXF file having one closed polyline with the tunnel template. We select the DXF file, and now you can see that it's simply a closed polyline with a reference point that is the point point for the horizontal and vertical alignment. We can copy this polyline, giving this reference point, and simply paste it. And also we can add control points that they are useful for other further operations. Is defined. You can see here. You can see here the theoretical template, and now we are going to assign the template this template to the final station. TCP scansing allows you to have different tunnel templates, and it can interpolate the template using control points. Now that we have the cross sections calculated and also the tunnel template, we can compare them. It's very simple. We can check this, and let me hide some layers. And you have here the dimension, the different, and the representation in colors. In red is under break, and green is over break. So you can, and you have here the areas. Let me show the representation of areas, and you can see easily in this way how is our tunnel. Of course, we can export, we can draw this, and in this case, exporting to DXF, exporting in 2D or 3D, and a single cross section or a range of cross sections. We select this range, and we can select which elements, which information we want to be labeled, and specify the paper size and scale on all parameters. We give a file name, and now press OK, and the cross-section file is being created, and now we can open the CAD and see how is our drawing. You will see that it's a very simple process. Now we'll do a zoom extension. And this is our tunnel. You can customize everything about which element you want to label, or size, the sheet size, and the size of text, and everything, all parameters. We can also get this information as a report, area and volume report. There are different report types. We select the template for comparing the tunnel project with the as-built data, and we can also select this option for giving not only the total data but also these subgroups. Calculating, and now we have 3 reports. One for this is the total, and different tabs for top heading and bench. And this is what I wanted to show previously. We have here the excavated area, total excavated area, missing area that is inside the tunnel template, and the area that is outside the tunnel template. Here for every cross section, and of course we can export this information to text, Excel, or HTML. There are many other formats, many other types of reports. Maybe the most important is the comparison of cross-section. We can compare, we can add different cross-section files and compare them. In this case, we can compare this cross-section file with this one. In fact, this example has changed only the first 5 meters. Is only for demonstration purpose, but you can see that here is the result. Other interesting reports are cross-sections, control points, and Gauss report to check that a vehicle will fit the template, Google report, and many others. Now we can get not only reports but also maps. I'm going to show you the inspection map. This command will create an image in which the color of each pixels will depend on the distance between the as-built data and the tunnel template. Let's input the data, the station interval, the image width, and we can give an interval of 40 centimeters, positive and negative, and we'll assign blue for positive and red for negative values. And we'll give a file name, and then is calculating the spectrum mass and will show data. Now you can see the x-axis is the station and y-axis is the developed template, and the color you can see here the legend with colors. So that blue color means positive and red color means negative values. We can do a similar map. It's an ortho image where we are going to give the same parameters, and in this select intensity, and we'll give a image width so that each pixel will have about 5 centimeters. And this is the result. It's similar, but now you can see the intensity values along the tunnel, along the developed template. We can assign, also a nice feature of this software is that you can assign a different point symbology. For instance, now we are going to assign a point symbology depending on the distance to template, and we'll give the same values and a color palette and a similar color palette, red and blue, so that you will see in 3D the points color with a color depending on the distance to the theoretical template of tunnel. Now you can see how red points are areas in which you need to excavate, and blue points are areas in which the excavation is other pages. And you can also create a simulation traveling along the tunnel, and we can input a starting point and start simulation. We can, for instance, increase the speed. We can stop at any point and look in any direction to check how is our tunnel with this kind of representation. For instance, this is the access to gallery. And even we can export this to AVI file to send to your customers. It's a very nice feature. You can move in the opposite direction. And well, we don't have enough time. There are many other options. Now I am going to, of course, we can create 3D models, but let me open directly the result of this model. It's very similar to the process you have seen previously with TCB Tunnel, in which we can create an OBJ format, and like this. This is the 3D model of our tunnel, and you can open it with different tools like this, like in this case, Cloud Compare. So that's all from my side. I hope you have enjoyed this software, and please feel free to ask your questions, and we will try to show you.
Thank you, Francisco. Yes, as we said, if you have tunnel project, you can easily contact with our distributors or directly with us in order we can prepare you a specific demonstration of your needs. To finish this webinar, before to say thank you to all the assistants, you can download the information into our web page. Here you have to download the dossier, or here a free trial version during 30 days. Okay. Also, this webinar has been recorded. So in the function of Appletop Academy video library, you will find all this webinar we are managing in English actually, and this webinar about tunnel solution. We just finished to say that we have several social networks. Please don't hesitate to follow up. You will have a lot of information about new update, about new webinars or formation about our solution. Thank you very much to everybody for all the assistance. Was a huge webinar with a lot of assistance, and we hope you have enjoyed it. Thank you very much about everybody, and see you soon. Bye-bye.